Hello everyone. The focus of this lecture is on indeterminate forms. My aim is to show you the indeterminate forms of limits and actually giving the list of these types of limits. So I'm not going to focus on the approaches for solving of them. As you know, we need to identify them first, and here I'm going to show you all possible indeterminate forms of limits. And in our future lectures, we will focus on approaches for solving them. Let's start. An indeterminate form is an expression involving two functions whose limit cannot be determined solely from the limits of the individual functions. The most common indeterminate form can be seen in evaluating limit of a ratio function such as fx over gx, where the limits of both f of x and g of x are either 0 or infinity. Therefore, the limits will be in the form of 0 over 0 or infinity over infinity. We know that basically computing the limit of indeterminate forms is the fundamental problem of differential equations. I will explain why they are like the fundamental problem in solving differential calculus, and we will see basically when we are defining derivatives, the definition of derivatives is a form of indeterminate limits. We have different approaches for solving of indeterminate limits, but the idea here is just first identify them, and after knowing what are indeterminate forms and how many indeterminate forms we have, in the next lectures we will focus on approaches for solving indeterminate forms. Let's start with actually working on the categories of indeterminate forms. The first indeterminate form, and basically one of the most common indeterminate form, is 0 over 0. So as you can see in here, we have actually a ratio of x squared minus 4 over x squared plus x minus 2 in here. So this is actually the function that we have. And if we plug in minus 2, so you know that the first thing that when we want to solve a limit is to plug in the number that we are approaching to it. Or if it is infinity, again we have to plug in and evaluate the function to see is this function actually indeterminate form or not. If it is, we have to use some approaches to solve them. So here, let's plug in minus 2. If we plug in minus 2 in this function, this is going to be minus 2 squared minus 4 over, and we have x squared, so it's going to be again minus 2 squared plus minus 2 minus 2. And we know that minus 2 squared is going to be 4, therefore it is going to be 4 minus 4 over again minus 2 squared, so it's going to be 4 minus 2 minus 2, so it's going to be 4 minus 4, and at the end we will have 0 over 0. So as I said, we are not going to solve the limit fully in here. We want to show what are the indeterminate forms. So here we have 0 over 0 for a fractional function, and we have some sort of techniques to solve them. In future lectures we will see how we can solve. Next, look at the second indeterminate form that we have. This one is infinity over infinity, and as you can see, the value of x is approaching to infinity. If we plug in infinity here, it's going to be infinity easily, because instead of x, if we plug in infinity, it is going to be infinity, and e to the power of infinity, which is a form of exponential growth, so it's going to be a very big number at the end. So this is basically infinity over infinity. So this is the second form of indeterminate limits, and again one of the most common forms that you can see when you are dealing with indeterminate limits. The third one is 0 times infinity. So 0 times infinity happens, as you can see in this example, we have x cubed times e to the power of 1 over x, and we can have lots of examples based on this indeterminate form, but easily again we have to plug in the number that we are approaching to it. So it's going to be 0 to the power of 3, which is basically again 0 times e to the power of 1 over 0 positive, which means it is positive infinity. So it's going to be 0 times e to the power of infinity, and at the end it's going to be 0 times infinity. So as you can see again, we have 0 times infinity, and this is an indeterminate form. So we have to use again some techniques that we will see in future lectures for solving this kind of limits. The fourth one is 1 to the power of infinity. So again, this is an indeterminate form, and when you are dealing with this kind of indeterminate form, again you have to use some techniques to solve them. So the first thing, let's look at this example. We have limit of 1 plus sine x to the power of 1 over x, and what we have to do, we need to plug in 0 positive instead of x. So it's going to be the limit of, or let's say it's going to be 1 plus sine 0 1 over 0. So as you can see again, it's going to be 1 at the end, because 0 sine of 0 is 0, so it's going to be 1 to the power of 1 over 0 positive, and we know that it is actually positive infinity, so it's going to be 1 to the power of infinity, which is again an indeterminate form. Another form of actually indeterminate limits is 0 to the power of 0, and again it is possible to have this form, especially when we are dealing with this kind of functions. And as you know, if we plug in 0 in here, it's going to be 0 to the power of 0, and 0 is going to be to the power of 2. So it's going to be at the end 0 to the power of 0, and we have to cancel this indeterminate form, and we have actually somehow address it, and using some kind of manipulations or techniques that we have in calculus to solve this kind of indeterminate forms. Another one is infinity to the power of 0. So when x is approaching, for example, for this case, x is approaching to infinity, we have the limit of x to the power of 1 over x, and if we plug in infinity here, it's going to be infinity to the power of 1 over infinity, and we know that 1 over infinity is actually 0, so it's going to be infinity to the power of 0. And again, it is possible to see this kind of indeterminate forms, and we need to use some techniques to actually get the final answer for this forms of limits. And the last one is infinity minus infinity. So again, this is an indeterminate form that we have to use some techniques to solve them, and easily if we plug in infinity here, so it's going to be a square root of infinity squared plus infinity minus infinity. So infinity squared plus infinity is infinity is going to be infinity, so it's going to be infinity, so we will have infinity minus infinity, which is an indeterminate form. Okay, as you have seen, we have like 7 different forms of indeterminate limits, and in our next lectures we will discuss how we can solve these 7 different forms, and then with lots of practices you can be easily the master of limits, especially indeterminate limits. And for your exams, especially for calculus 1, there would be a few problems that you should be able to solve them easily based on the techniques that we will see in the next lectures. Thank you very much for watching this video. If you enjoyed, please subscribe our channel.